Good morning, students. Today I'll discuss pass transistor. What is a pass transistor? Pass transistor is nothing but NMOS transistor or a PMOS transistor. So why do we call that as a pass transistor? When we apply or when we turn on this transistor by applying logic high, whatever voltage we apply at the input, that is at one end, it looks as if it appears at the output. So it just passes whatever logic voltage that is appearing at one end to the other end. How it does? Let us understand. Same thing happens in case of P MOSFET. If we turn on P MOSFET by applying negative voltage to the gate terminal. So here, let us try to understand how this works. So first, assume that you are applying VDD voltage here to the gate terminal. So initially output voltage is 0. When we apply logic high voltage, what happens? This gate and the other terminal which is having initially low voltage acts like source. So the voltage difference between gate and source terminal is now greater than the threshold voltage of the MOSFET. Therefore, the MOSFET will conduct and turns on. So when it is on, the on resistance is very less. So logic high voltage will be connected to this end through this on transistor, and therefore at this end you get logic high. Same thing happens when you apply logic low at this end. When this N MOSFET is already turned on by applying logic high to the gate terminal. So even if initially the output terminal has logic low, the gate to source voltage will be greater than the threshold voltage of this N MOSFET, and this turns on, and this point, that is input point, is connected to the output point through a small resistance of this MOSFET, and therefore this logic low voltage will appear at this output terminal, and this circuit just passes the input voltage to the output voltage. So under two conditions of input, we verified what is going to be the output, and in both the cases it appears same as the input voltage. So here in this diagram we see whatever we understood in the previous slides. So for N MOSFET, if we turn on the MOSFET by applying high voltage to the gate terminal with respect to source terminal, then it turns on, and the logic low voltage is going to appear at the input, and the same logic low voltage will also appear at the output. If we apply logic high voltage at the input, the same logic high voltage will appear at the output. Electrically, the value of that logic high voltage now is VDD minus the voltage drop between gate and source, that is threshold voltage. So VDD minus threshold voltage will be the voltage that comes or appears at the other terminal. In the P MOSFET, we have to turn on the P MOSFET by applying 0 voltage. So 0 minus other terminal voltage, even if you think the other terminal is initially high, 0 minus high voltage will be minus high voltage. So the P MOSFET will turn on, And if you apply 0 logic low here at the input terminal, what happens is the device is on. So the logic low is connected to the output through this on transistor, and the output now will get low voltage. So here, instead of getting exactly 0 volts, you get VTP, that is the threshold voltage drop across the uh, source terminal. So here, in this case, the P MOSFET is turned on by applying 0 voltage. And when we think the other terminal is high, that is VDD, and if we apply input voltage VDD here, that is logic high, so 0 minus VDD is going to be minus VDD, so the transistor is expected to turn on, and this input voltage VDD is connected to the output terminal through this on P MOSFET, and the output terminal continues to remain at VDD. So it appears as though we are passing the input voltage to the output voltage. So here, if we connect a series of pass transistors in this fashion, what will happen to the voltage levels? That we will try to understand. So here, in all these cases, for all these devices, we apply gate voltage equal to VDD, and to one end we apply VDD here. So in first MOSFET, the voltage at this end is VDD minus the threshold voltage drop, because this terminal will act like source. So VDD minus VT will be the voltage drop here at this terminal, and this acts like input voltage for the next MOSFET. And though this works as a pass transistor, what you should know here is you get a voltage drop at this terminal VDD minus threshold voltage of this MOSFET. So you get VDD minus VTN here. And next, when this device turns on because of this VDD applied to gate terminal, what voltage you get at this terminal is VDD minus threshold voltage of this transistors, that is third transistor. So you get VDD minus VTN. So although you have three MOSFETs, you get VDD minus VTN at the output. So this still is a logic high voltage. So you can pass logic high voltage from one point to another point by connecting series of pass transistors. But if you try to connect pass transistors in this fashion, let us see what happens. So you apply gate voltage VDD, and to one terminal you apply VDD, the other terminal acts like source. So what is the voltage you get here? You get VDD minus VTN, and that is applied to the gate terminal here. So when you apply to one terminal which acts like drain, VDD, the other terminal here now gets gate minus the threshold voltage of this MOSFET. What is the gate voltage? VDD minus VTN. What is the threshold voltage of this MOSFET? VTN. So VDD minus VTN minus of VTN will be VDD minus 2 VTN. And that is the gate voltage for the third MOSFET. And for this MOSFET, when the drain voltage is VDD, at the source you get voltage equal to VDD minus 2 VT minus of VT of this MOSFET, that is VDD minus 3 VT. So there is degradation of voltage levels at the source end here. So if you connect the MOSFETs in this fashion, logic high will be degraded. Initially it was VDD, then it became VDD minus VTN, VDD minus 2 VT, and then VDD minus 3 VT. So at some, if you continuously connect MOS transistors in this fashion, at certain point you will get a degraded logic high voltage which can be understood as a logic low voltage. So we should not use or connect MOSFETs in this fashion to pass logic levels from one point to another point. And in this figure, we have a circuit called transmission gate. Why it is called transmission gate? That is because when we connect two transistors, one P MOSFET and one N MOSFET in parallel, and apply a logic signal A here at the input, you get again same logic voltage or